Now, all of you have graphed a linear equation before. You could use slope-intercept form, find the slope, find the y-intercept, graph it from there. You could use the t-table and all that, right? So you have graphed lines. So for example, when you graphed y equals negative 2/3 x plus 1, let's say, when you graph that. First of all, notice from a previous course that this is in what form? When y is by itself. Slope-intercept form. That's the slope-intercept form. So remember that y equals mx plus b? Y equals mx plus b? So that's slope-intercept form. So sometimes a Christmas break will make you forget things.
Yes.
So y equals mx plus b, where the coefficient of x is the slope. And remember, slope is rise over run, you all that? And b is your y-intercept, where the graph crosses the y-axis. So based on that information, what is the slope of this line? Negative 2/3. That's what you're multiplying x by. What is the y-intercept? What is b? 1. So remember, b is your y-intercept. That's where the graph crosses the y-axis. And so what you did was this. That's one of the, and the other thing you did was use a t-table. But most people keep forgetting about slope-intercept form, so that's why I'm kind of talking about that. So when you graph using slope and intercept, you plot this intercept first, the y-intercept. So where does the graph cross the y-axis? No, that's your slope. At 1. That's what we said the y-intercept was, right? Y-intercept is b. That's where the graph crosses the y-axis. That's what y-intercept is. X-intercept is where the graph crosses the x-axis. Y-intercept is where the graph crosses the y-axis. B is always the y-intercept. That's your y-intercept. So the graph's going to cross the y-axis at the point 1. So here's my y-axis. Let's say this is 1 right here. So that's a point on the graph, on this line. To graph a line, how many points do I need? 2. We need 2 points. Okay, so I know 1 already. I'm going to use a slope to do the other. What's the slope? Rise over run. Okay, so I'm going to write it like this. I'm going to write it as negative 2 divided by 3. And negative 2 is my rise, and 3 is my run. Rise over run. Well, let's talk about the rise. Rise meaning going up and down. So if my rise is positive, I go where?
Down.
If my rise is positive, I go up. If my rise is negative, I go down. Okay? Rise, up and down, just like the y-axis. My run is where you go left, right, horizontally. If my run is positive, I go to the right. If my run is negative, I go to the left. Okay? All right. So you had that in Math 98, the idea of slope.
But it doesn't matter if you do which one, right?
No, it doesn't matter. We normally do the rise first. Okay, so let's. She's asking, do you have to do the run first, or can you do the rise first? Doesn't matter. We tend to do the rise first. All right, so we start at the y-intercept. From that y-intercept, I'm going to rise either up or down. Is it up or down? Down. How many units? 2. So I go, remember this is 1 right here. I go 1, 2. Now don't put a dot there. That's just where you are, right? So that's so far this is negative 1. Y'all agree? All right. So I went down 2. Now you do your run. My run is a positive 3. I go which way? To the right 3. 1, 2, 3. So there's the other point. What are the coordinates of this point I just plotted? 3, comma, negative 1. And so you just draw your line, and there's your graph. So that was just a quick review on remembering how to graph a line, but that's not the intent of what we're trying to do with systems for this moment. But what I want you to remember is this, that you see that point, that y-intercept, any other point of that line, how many points are on this line? An infinite number. All those points represent solutions, right?
Yes.
Remember when you graph a line or graph a circle or graph whatever relation you have, you're graphing solutions. These are all solutions. So that equation up there, y equals negative 2x plus 1, has how many solutions? And remember, those solutions are ordered pairs. They're ordered pairs. And so how many solutions are there?
Infinite.
An infinite number. There are infinite number of solutions to this linear equation. So if I look at this idea, x plus y equals 7. If I look at x plus y equals 7, now this equation, this linear equation, is easy enough to where you can tell me at least some solutions. How many solutions are there? An infinite number. You can tell me one of them. Give me an ordered pair in which the left side equals the right side. Huh? 3, 4. Very good. 3, 4 is one of them. Do y'all agree that if I asked you to list some solutions, 3 plus 4? 3 comma 4 is a solution to that linear equation. So if I would graph this, that would be on the graph, wouldn't it? Yeah. Because x is 3, y is 4, and then the equation says x plus y. Well, what's 3 plus 4? And 7 equals 7. What are some other solutions? 5 and 2, okay. 5 and 2 is a solution. 6, 1. Let's do some negative ones. 8 and what? Negative 1, good. Because 8 plus the negative 1 is what? 7. But the point being that all of these are solutions. And how many solutions are there?
Infinite.
An infinite number. There are infinite number of solutions. Okay? Now what about this one? X minus y equal negative 1. X minus y equal negative 1. So some of them are easy to get. I mean, there's an infinite number, but all of you can at least tell me one distinct solution from anybody else. 2 what? Minus 2 and a negative 3, okay. Y'all agree? Do y'all agree? Oh, no, she said this. She said this, 2 and a negative 3. She says that's a solution. What? Okay, now be careful. Huh? 2 and 3, yes. Not this, because x is 2 and y is what? Negative 3. So when I go here, 2 subtract the negative 3, 2 subtract the negative 3 is 5. What do I want? Negative 1. What you meant to say was 3. Is that?
I said 2 minus 3. Like, that's not funny.
No, but I asked for the ordered pair. So you had to say 2 what?
Okay. 2 and 3.
Positive 3. Right. The ordered pair is 2, 3. That's a solution. Okay? Because 2 minus 3 is what? Negative 1. Give me another solution. Huh? 0, 1? Very good. 0, 1's a solution. 0, 1's a solution. Because look, 0, 1's a solution. Because 0 minus 1 is what? Negative 1. What's another one? Come on, y'all are smart enough to tell me what another one is. What? 8, not 8, 11. Because what's 8 minus 11?
11 and 10.
11 and 10, okay. Oh, no, not 11 and 10, but 10 and 11, right?
10 and 11, yeah.
Okay, so she said 11 and 10 first, and that's fine. And then she figured out that, no, that's not correct because she went to the equation. She said 11 and 10. What's 11 minus 10? 1. So that's obviously not a solution. But 10, 11 is, because what's 10 minus 11? 1. But how many are there?
Infinite.
An infinite number. Do y'all agree that 3, 4 is a solution?
Okay.
Yes? Because 3 minus 4 is what? negative 1. In fact, knowing that pattern, you can say if x is 6, then what should y be? No, not 5, because 6 minus 5 is 1. 7 is what I was hoping you would get. If x is 12, what's the other one? 13, because 12 minus 13 is negative 1. So they're given a number. But here's a question, though. So you saw where 2, 3 was a solution to that equation? Is it a solution to that first one I did? See how 2, 3 is a solution here? Is it a solution to this one? So is the point 2, 3 a solution to x plus y equals 7? No. Because when I substitute 2 for x and 3 for y, what's 2 plus 3? 5, and 5 does not equal 7. So if I were to graph x plus y equals 7, would the point 2, 3 be on that graph? No. Okay, so when I look at these two equations, there's only one point here and one point here that they have the same solution for. What is it?
3 and 4.
3 and 4. 3 and 4. 3 and 4. The point 3, 4 is the point that both of them share. Okay? Now, that's important because we're talking about the word system. So let's talk about what we mean by system. Okay, so listen carefully. We're talking about the word system. So a system a system of linear equations. Now we're talking only about linear. We're not talking about anything that has quadratics in it or anything like that. We're just dealing with linear. A system of linear equations. A system of linear equations is a collection of two or more equations, and for us we're just going to deal with two, but you can have more than two or more equations involving the same set of variables. All right, so a system is a collection of two or more equations that have the same set of variables. Now, there's a bit more to that, but so far what that means is this. So last semester and the semester before that, we just graphed lines individually, right? Mm-hmm. Okay. What we did today was we looked at two equations. We looked at the solutions of the first equation, we looked at the solutions of the second equation, and we noticed that there was a point that was a solution to both, right? And what was it? Was 3, 4? The point 3, 4? Okay. The word system indicates that the equations are to be considered collectively rather than individually. All right, so the idea of a system, when we talk about a system, you're looking at not just one equation by itself, but for us it's two, so you're looking at two equations together. Now here's what the notation is going to look like. In the past, in the past, and even the one we did today, I asked you to graph this line. Do you remember that line that we used the slope-intercept form with? Okay, so somewhere here, somewhere. But we used the slope-intercept form to graph that line. Usually in the past you would have said graph this line, right? I could have easily asked you to solve this equation. And one way to solve the equation is to graph the solution, and the solution would be the points of the line. But we don't do it that way. We just say graph the line. You just have to know that when you graph the line, you're graphing the solutions. That's what you're graphing. That's what you did in previous courses. That's what you were told. You have to make a connection between why am I graphing these lines? Well, these are solutions to this line. We talk about a system, though. When we talk about a system, here's the notation. I'm going to use those two equations we did earlier. So the two equations were, so the system notation is going to look like this, notation. You may see a brace. Some textbooks use a brace. Some don't. It'll be a brace. It looks like this. And then your two equations will be listed. So the first one we had was it was x plus y equals 7. And the other one was x minus y equal negative 1. So when you see that notation, where you have two equations that are written collectively, you're looking at what kind of situation? A system. You're looking at a system. And what you're going to be told is this. You'll be told to solve this system. That's what you're going to be asked to do. So the direction will say, solve the following system. Solve the system. Okay, well, let's talk about what we mean by solving. So solving means to find a solution, correct? Okay, and I kind of gave it away earlier. We had our discussion, but you know what the solution to that system is. What's the solution? 3, 4. 3, 4 is the solution. We had the discussion. Remember our discussion? We said the only point that this line, that first line, x plus y equals 7, the only point on this line, and how many points are on this line?
Infinite.
An infinite number. All of these plus a lot more. An infinite more. And the only point on this line that they shared was what point? 3, 4. No other point was on that line that they shared. 3, 4 was the only point that both of them had the same solution for. And you can check it. What's 3 plus 4? 7. What's 3 minus 4? Negative 1. So 3, 4 is the solution to that system. Individually, each equation has how many solutions? Infinite number. Collectively, they have how many solutions? 1. That's the difference between graphing an equation individually versus talking about them collectively. Collectively, you're referring to it as a system. Individually, you're just saying graph the equations, graph the solutions. That's the only solution. So 3, 4 is the only solution. Okay. Now let's go ahead and do. I don't think I have graph paper. No, I don't. So let's kind of do this as carefully as possible by hand. So what I want to do is I want to show you that when I graph those two equations, I want to show you what happens. All right, we already plotted some. We already know some points for the first equation. One was 5, 2, 1, 2, 3, 4, 5, and then 2. So there's a point on the first one. And then 8, negative 1 was the other. 6, 7, 8, negative 1. Now I'm doing it by hand, so it's not going to be, I'm going to kind of cheat a little when I do this. So there's the line. So this is x plus y equal 7. X plus y equals 7. Now remember, all I did was I just used two of those points, right? Because how many points do you need to graph a line?
2.
2.
3
I'm
to
gonna-
check.
3 to check, but that's if you're using a t-table. Now let's go ahead and do the other one. So let's plot two of those points that we came up with. So one of them was 2, 3, right here, and the other was 0, 1, which is here. Okay, and then you see what I'm doing? I'm just picking 2 points that we came up with. Now there's one that I specifically not going to use because it's going to kind of destroy the conversation. So I'm going to graph that line, and I get this. So this is a line, x minus y equal negative 1. Okay. Now, those two lines, they intersect. How many places they intersect? 1. Now, I did it by hand, but where does it kind of look like where they intersect? 3, 4. That's where it looks like they intersect. They intersect at 3, 4. 1, 2, 3, 1, 2, 3, 4. So when solving a system, one way to solve a system is to graph it. That's not the way you want to do it. Because you have to be very careful with how you graph things. But one way is to do this by the graphing. And the point where they intersect is called the solution to the system. So when solving a system by graphing, the point of intersection is the solution. So the point of intersection is a solution. And it kind of makes sense because all of these points right here are solutions to this equation. All of these points are solutions to this equation. And what's the only one that they share? 3, 4. So what's that solution to this system collectively? 3, 4, the point of intersection. All right, so when graphing a line, when graphing two lines, the point where they intersect is called the solution. Okay? All right. So any questions on solving a system by graphing? Solving a system by graphing. So real quick, I want you to go ahead and do number 2 on this one. So we get this. Look at this. So it says solve each system by graphing. I have rulers. These are borrowed rulers. I need them back though. When the ruler's back, they have a tracking device in it, by the way. So just beware. There's a tracking device in this thing.
Yeah, but we live close to each other.
So number 2,
We do.
you have y equals x plus 4 and y equals negative 4/3 x minus 4. What is the slope of that first equation when you look at that? No. What's the coefficient of x, the first equation, number 2? No, if there's no coefficient, what's the number supposed to be? 1. Slope is 1. You write 1 as 1 over 1. What's the rise? 1. What's the run? 1. What's the y-intercept in that first equation? 4. What's the slope of the second equation? Negative 4/3. What's the rise?
4.
Negative. I would put the negative in the numerator. What's the rise? Negative 4. What's the run? 3. What's the y-intercept? Negative 3. So take about 5 minutes, help each other, graph this. Now you can use a T-tape if you want to. You don't have to use slope to intersect. Is that clear? You can use a T-tape. But those two lines should intersect how many places? One. The place where they intersect is called the
Solution.
solution to the system.